Hey everyone, welcome back to the YouTube channel of Developers and Coders Club. We are here to discuss the crawler station operation, which is part of recent contest of CodeChef that is started in 94. So in this question, we will be given a matrix A consisting of n rows and n columns. And our task is to select an element A xy such that the following value is maximized. So we are going to select a xy such that this term should be maximized. And what this term want to say that we need to select an element AXY such that the sum of bitwise XOR of AXY with all elements that are not in the X row and Y column should be maximum. What it means to say that if this is the given matrix to us and we select this as our AXY, then uh, remove this and this. Like don't consider these elements and XOR of AXY with all elements which are not part of the X row and the Y column. Sum of XOR of those elements should be maximum. So if this is X, then XOR of this and X, XOR of this and X, XOR of this and X, these all, and sum of that, summation of that should be maximum. So we want to print the summation of that. So for each test, the output and nil and the maximum sum which we can get. So like in this grid, 1, 2, 3, 4, 5, 6. This is given to us. Now if we select 4 edge over axi, then what will we do? We will not consider these elements. Remaining elements is 2 and 3. 2 XOR 4 plus 3 XOR 4. So 2 XOR 4, that is 1 0 1 0 0. So that will be 0 1 1. And 3 XOR 4, that is 1 1 1. So this is 7, this is 6, 7 plus 6, that is 13. And that is the maximum which you can get by selecting 4. So we are printing 13 here. So now for like what is the basic brute force approach which you can get? Like if we consider a brute force approach, most naive approach, then what will you do? That for each element of this matrix, for each element we will iterate for complete grid, and we will not iterate on the row, the particular row and this column, and we will XOR on all elements which are not part of this and this, and we'll sum of that, and we will check that is that maximum. So like I want to say that we will iterate for every element, and on that element we will iterate on complete grid again, and we will make the XOR of that element with all elements which are not part of this and this, and sum that, and then print the maximum. But in that case, what will be the time complexity? That is O of n square for iterating that particular element, and into n square for iterating the calculating the XOR value. So that is O of n 4, and obviously that is not feasible. So now what we can do for that, just tell me that if I say you that you need to calculate the sum of this one, okay, you want to calculate the sum of this to make it 0. Now what will be the sum? That will be 1113. 1 is here, then 110, 1 is here, 0, 1 is here, and this is 100. So I think that is right. This is uh, 11, this is 9, this is 9, this is 4. So 20, 20 plus 9, 39, 29, 29 plus 4, that is 33. So yeah, that is correct. So that how we are going to calculate this sum? Now instead of this, if I say that on the that I am calling this first bit, this is second, this is third, this is fourth. Now if I say that on the first bit there is three ones. On the second bit, there is only one one. On the third bit, there is one one. And on the fourth bit, there is three ones. Now from this data, you can make a sequence like on the first bit, there is three one. Okay. Second bit, only one. Third bit, only one. Fourth bit, three one. Now sum of this and this. Obviously that will be same. This is 15, this is 9, this is 9. So 15 plus 18, that is 33. So yeah, that is same. So now what I want to say that what we are going to do, that we are like if you are selecting AXY, then what will you do? That AXY XOR with A11 plus AXY XOR with A12. In this way, AXY XOR with A and M. Now in this complete part, if I say you that number of ones in first bit is this, number of ones in second bit is this, third bit is this, and 31, 32 bit is this. If I give the data of these in number of bits, number of ones on all bits, then obviously you can calculate the sum. How we are going to calculate that? That if I consider this part, where is that? Okay, so number of ones in first bit, that is three ones. So take three. Number of ones on second bit, that is one. So plus two into one, plus four into one, plus eight into three. That means power of two, number of bit minus one multiplied with number of ones. Summation of this for every bit from 1 to 32. Is that is correct? 3 plus 2 plus 4 plus 24. So this is 5, this is 28, so yeah, that is 33. So if I give you this, then you can calculate the sum. And how we are going to calculate that? Power of power of 2 bit minus 1 and multiply with number of ones in that bit. Now how we are going to calculate the number of ones on a particular bit? So for that we are going to using prefix sum. So one thing which we can consider that if your AXY, like what I am going to do, I will iterate for every AXY in the grid. I will iterate for every AXY and I will check that in this area how many ones are on first bit, how many ones are on second bit. After taking XOR with this, like this element XOR of this and this, XOR of this and this, XOR of and this and this. In all these elements, how many elements are there on which ones are there on their first bit? How many elements are there on which one is there on their second bit? So if you have that data, then you calculate the sum. Now for that we are going to use prefix sum, and prefix sum of n, and 31. Now one thing which we know that if you are getting the XOR of that, then in this AXY, if on a particular ith bit 1 is there on this AXY, then what you need to calculate that in that case you need to calculate the zeros number of zeros on all bits, because if you are calculating that, then the 1 XOR that 0 will make 1. Okay, so if on the ith bit there is 1, then you want to calculate the number of zeros on every bit, because that will produce 1. And if that is 0, then you have to calculate the number of ones, because XOR of 0 and 1 will make 1. So let's see the code. So here first of all I'm taking the input, then prefix of this is the prefix array, then loop. This is how I am calculating the prefix. That is prefix of ijk will be equal to, if you are calculating the prefix of this element, that will be equal to prefix of I minus 1 j, that is this part, prefix of I and j minus 1, that is this part. But as you can see that this part is calculated two times. So for that you are subtracting that. So now that is calculated only one times. Then you are adding for this one. That what is the bit on that this uh, index. So for that array of I minus 1 j minus 1, because I am making this one based prefix sum. So array of I minus 1 j minus 1, k times left side and add with 1. That will give us the what is the on kth bit. If that is 1, then 1 will be added, otherwise 0. So prefix of ijk is holding the value that what is the count of ones on kth bit from grid 00 to ij. Okay, what is this holding? That if this is ij, then the count of elements which are holding 1 on their kth bit from this segment. Okay, then you are iterating for every element, and then okay, so that is not this, ignore this one. I'm not making any use of this flag. That is only used for debugging the code. So on the kth bit, I'm calculating that if array of I minus 1 j minus 1, that is and with 1, that is 0. That means in the or array of xy, on the kth bit there is 0. In xy, on the kth bit there is 0. Then we want to calculate the number of elements which are holding 1 on their kth bit, because XOR of that will produce 1. So for that you want to calculate the number of ones, and our prefix I'm also holding that thing. So count plus, this is for 00 to I minus 1 j minus 1, because we know that if this is our grid, then you are considering this element, then you need to consider this grid, this matrix, this matrix, this matrix, and this matrix. So this is for this one, 00 to I minus 1 j minus 1. Then for I plus 1 0 to n and j minus 1, I plus 1 0 to n and j minus 1. This is for this one, n and j minus 1. This is pointing to this, and I and j minus 1. This is pointing. Oh, okay. So what is the mean of this one? N and j minus 1. That will point to this complete matrix, n and j minus 1. But we want to subtract this one. For that, index of this will be I and j minus 1. So I and j minus 1 on the cat bit. So this is holding the count of all elements which are holding the 1 on their kth bit. This is for this one. This is for this one. 0 to j plus 0 j plus 1 to I minus 1, and 0 j plus 1 to I minus 1. This is for this one, and this is for this one. I plus 1 j plus 1 to nm. Nm and j that is pointing to nj that is pointing to this one. N and j, this is n and j. Im that is pointing to this one. Okay. Nm that is pointing to this complete matrix. Nj this one. I have added this one, but I am subtracting this one because we want to consider only this one. So I have subtracted this one. Then I have subtracted I and m, that is this one. But as you can see that we have subtracted this two times, so we have to add this one. So prefix of I and j is added. So from here I'm count is backing that how many elements are there which are holding 1 on their kth index. Okay, this is if that is 0, but if that is 1, like in axy, the kth bit is 1. In that case, we want to calculate the number of zeros. So for that we, like in this case, okay, what we want to do, we want to calculate the number of zeros in this matrix. For that we have the number of ones in this matrix, and we will subtract that from I minus 1 j minus 1. That is the number of total elements in this one. So the number of total elements in this one minus the number of elements which are holding 1. That will be equal to number of elements which are holding 0. So now this is for this one. Now for this one, n minus I and j minus 1. So that is pointing to this one. That is this one, and that is this one. So you can see you can get the code from description. Now this is the complete count. Now we have, this is the count which are pointing to the number of ones on every bit. What we will do? Count multiplied with 1k. What is the mean of this? That is to the power k. And as you can see that k is starting from 0 to 32. So I will not subtract minus 1. So this is sum, and we will print the maximum of these all sums. That will be our answer. So you can get the code from description. I hope you got it. See you in the next one. Till then, happy coding. Bye.